Okay, welcome to the late night talk with the weird name. We're going to be presenting a targeted attack on an average company network. And what's going to be special about this attack is that we use lots of little bugs, which themselves don't really seem to have that much of an impact. But as we chain these bugs, as we put them together like the pieces of a jigsaw puzzle, you actually get a really dangerous kind of attack. So these are the things that we're going to be looking into. So we're going to do the entire thing. We're going to show how you get into the network, and once that you are in the network, before you can work all your layer 2 tricks, you'll probably have to bypass one filter or two, because just being in the network doesn't mean being in the network. You can land in different locations, and possibly you cannot reach the services that you want to compromise. In the end, we will then show how you can poison the Squid web cache in an attempt to control the entire HTTP traffic in the network. So this is the battlefield, and you're going to be seeing this throughout the talk, so you don't have to memorize it now. The only thing that's really important is that you are the pink bunny in the upper left. Apart from that, this is a very classical network design. Oh, one more thing. You're connected to the internet, and the network you want to attack is connected to the internet. Otherwise, this will just not work. Okay. So this is a very classical network design. What you have is called a DMZ. Basically what you do is you place all the services which directly communicate with hosts on the big bad internet into a separate zone known as the DMZ. And the rationale behind this is that if an attacker owns one of your machines which directly talks to hosts on the internet, then he's not yet inside the local area network, but just in the DMZ. He will still have to pass that internal firewall. So the question is, how do we get in? Well, due to the network design, it really does not make much sense to take the front door. And apart from that, you don't really have open SSH remote code execution in your pocket, right? Okay, all right, some may, okay. But if you do, you're probably not going to spend it on this network, right? Good. So there's actually another thing you can do, which is you can attack the clients. While they are not directly talking to to you, because they're using the web cache, they are processing an awful lot of data which you as the attacker supply. So if you look at the stuff that's on the client, you have this gigantic zoo of technologies all ready to exploit. So there's different media players, and then there's Flash, and you have different instant messengers, and entire desktop environments, antivirus, all that kind of stuff. So there's a huge attack surface for you. So you're probably thinking, yeah, just find some buffer overflow, some sort of memory corruption, and then that's it. We just own that box. Well, it's not that simple. It's not that simple because, first of all, how do you know what program the target user is actually running? So if you start spending all your time making that exploit work against Acrobat Reader, and then the person you're attacking actually opens this in XPDF, not good. And secondly, binary exploitation actually works very well when you have the binary that you want to exploit. You should know exactly how was this thing compiled. you know, what kind of, what version was this, stuff like that, so that you then actually know the addresses that you want to jump to. And once you know that, you still need to know what you actually want to execute. Because let's say you open up a bind shell in a network which is behind a network address translator. That wouldn't make much sense because you really can't reach it at all. So there is a sort of information gathering phase that we have to go through. And logical bugs often help you develop extremely stable exploits which do not rely on all of these little details for you to get that initial information so that then you can write your stable binary exploit. So what we're going to be exploiting is emoticons in Pigeon. So the admin in our network is Chatty, and he likes to use MSN on his Pigeon, and he has Linux because he's Leet. So for those of you who don't know, I hope there are some people here who don't know. These are emoticons. Somebody actually has to write code to make this work so that people can transfer these little images. What you see on the right is a body icon. That is something different. We're going to be exploiting that later. So right now it's emoticons. Okay, emoticons. In MSN, when you want to send an emoticon to someone, what you do is you say, I have these words here, best wishes, and whenever I type them, I want the other party to know that I actually want to send an image which is located at finger.jpg on my host. Okay? So now what the other party can do, and this is supposed to look complicated, what the other party can then do is say, I would like to request that emoticon. Because, you know, maybe the client doesn't even support emoticons, so then it would not have to request this. But if it does, it can. So this is a protocol, and it's very messed up, as you can see. It's basically a text protocol. But then you suddenly see that there are these parts of binary, the SLP header. And then as you look downwards, there's a base 64 encoded string. Base 64 encoded binary data. So you're thinking like, you know, there was binary up there. Why again that we base 64 encode? Right, to send binary in a text protocol. But we were just sending binary up there, so that doesn't make sense. And when you decode this, you actually see that this is text data. But now, here's what's really important. You actually get to specify the object you want to download. Okay, so you again say, this is the location I want to fetch. What do? You go fetch something else. And it works. So here's the code. It's very easy. And what's interesting is that it really looks like if you were auditing a web application, you would be expecting exactly these kinds of bugs. But this is actually something just above layer 4. So you're looking for totally different things, and then you see this, and you're like, wow, this stuff works universally. Okay, so it's easy. Object location is fetched. We then just append object location to purple smileys, get storing here, and then we just send it. ADM is also vulnerable because it uses libpurple. What's really scary about this is you don't have to, you don't have to have the other side tell you there's an emoticon here for you. You can just download without it telling you. So you can silently download files off that system.